Iceland revealed, where Earth is still being born. A planet under construction. What if we told you there's a place where you can watch Earth being born in real time, where tectonic plates pull apart before your eyes, creating new land each year, and where ice and fire collaborate to sculpt landscapes that shouldn't exist for another million years? What if we revealed an island so geologically young that humans arrived before the rocks finished cooling, where volcanic eruptions are scheduled events rather than natural disasters, and where glaciers carve valleys while hot springs bubble from the ground they've just shaped? Welcome to Iceland, the youngest landmass in the Northern Hemisphere, and perhaps our planet's most extraordinary geological laboratory. A place where the processes that created Earth continue working overtime, where you don't just observe nature, but witness planetary construction happening at speeds that make geological time comprehensible to human lifespans. This isn't ancient beauty preserved. This is raw creation in progress. Iceland sits astride the mid-Atlantic ridge, where the North American and Eurasian tectonic plates are actively separating at nearly 2 centimeters per year, pulling the island apart while volcanic activity fills the gap with fresh molten rock. The result is a living textbook of geology where you can literally stand with 1 foot on each tectonic plate while watching them drift apart. From volcanic craters still steaming from last decade's eruptions to glaciers that will completely reshape within this century, from geothermal areas where Earth's interior heat powers entire cities to black sand beaches created by lava meeting ocean just years ago, Iceland demonstrates that our planet remains a dynamic work in progress rather than a finished masterpiece. Before we explore where Earth reveals its creative process, subscribe to Travel Earth Adventures and hit that notification bell. Your support allows us to document our planet's most extraordinary phenomena while they're happening. Tell us in the comments, what geological process fascinates you most? Now, let's witness Earth still being born. Reykjanes Peninsula, where continents tear apart. Just southwest of Reykjavik, the Reykjanes Peninsula provides front-row seats to continental drift, the only place on Earth where the mid-Atlantic ridge rises above sea level, creating landscapes where you can observe tectonic plates actively separating while volcanic fissures demonstrate how new crust forms when continents pull apart. The bridge between continents allows visitors to walk from the North American tectonic plate to the Eurasian plate across a symbolic bridge spanning the Rift Valley where these landmasses are separating at the same rate fingernails grow. This pedestrian bridge turns abstract geological concepts into visceral experience where continental drift becomes personal and immediate. Recent volcanic activity in the area includes the 2021 Fagradalsfjall eruption that created new lava fields while providing unprecedented access for observers to witness volcanic creation safely. This eruption demonstrated how Icelandic volcanoes can be studied up close, transforming dangerous natural phenomena into educational opportunities that advance volcanic science. Geothermal areas throughout the peninsula release steam from fissures where superheated water meets surface temperatures, creating otherworldly landscapes where bacterial mats paint hot springs in oranges and greens, while sulfur deposits add yellows that create color palettes impossible in most natural environments. The peninsula's black lava fields, some only decades old, demonstrate how quickly life colonizes new volcanic terrain as mosses and lichens establish themselves on cooling basalt, beginning soil formation that will eventually support more complex ecosystems. Blue Lagoon, geothermal paradise. Created accidentally when geothermal power plant runoff formed a milky blue pool in a lava field, the Blue Lagoon demonstrates how human industry can create unexpected natural wonders while utilizing Iceland's abundant geothermal energy for electricity generation and district heating that makes the country one of the world's most sustainable energy users. The lagoon's distinctive color comes from silica and algae suspended in geothermal seawater, heated to comfortable bathing temperatures by Earth's interior heat rising through volcanic rock. The mineral-rich water has proven therapeutic properties while creating an ethereal blue that contrasts dramatically with surrounding black lava fields. Iceland's geothermal energy infrastructure harnesses heat from volcanic activity to provide renewable power that heats homes, generates electricity, and creates spa experiences, demonstrating how living on an active volcanic island offers opportunities alongside challenges when humans learn to work with rather than against geological processes. The Golden Circle, Geology's greatest hits. Iceland's most famous tourist route connects three geological phenomena that demonstrate different aspects of how active geology shapes landscapes while remaining accessible enough for millions of visitors to witness process that would require specialized expeditions in most other locations. Thingvellir National Park preserves the Rift Valley where tectonic plates visibly separate while also serving as the site where Iceland's parliament met for over 800 years, demonstrating how geological features influence human settlement and cultural development. The park's position between continents made it symbolically appropriate for Iceland's democratic assembly. The Glacier geothermal area gives its name to all geysers worldwide, while the active Strakur geyser erupts every 5 to 10 minutes, sending boiling water 20 to 30 meters into the air through processes that demonstrate how underground heat creates pressure systems that periodically release through surface vents. Gullfoss waterfall demonstrates glacial river power as a Vita River plunges 32 meters into a narrow canyon in two dramatic stages, creating mist that produces rainbows on sunny days, while showing how glacial meltwater continues carving Iceland's landscape through erosion that works faster than in most environments due to the soft volcanic rock. Vatnajökull, Europe's largest ice cap. Covering 8% of Iceland's total area, Vatnajökull Glacier demonstrates how ice sheets reshape landscapes while hiding some of Iceland's most active volcanoes beneath kilometers of ice, creating the paradox where fire and ice collaborate to create landscapes that exist nowhere else, while demonstrating how glacial and volcanic processes interact. The glacier's thickness reaches up to 1,000 meters in places, while its ice caves, formed by geothermal meltwater, create blue ice cathedrals that change annually as water carves new passages and collapses old ones. These ice caves provide temporary access to glacier interiors where annual ice layers preserve climate records while demonstrating glacial dynamics. Volcanic eruptions beneath Vatnajökull create glacial floods called Jökulsárlón, when subglacial eruptions melt massive amounts of ice rapidly, sending torrents down river valleys while carrying icebergs and sediment that reshape coastal areas within hours, demonstrating how quickly landscapes can change when geological forces collaborate. Glacier retreat at Vatnajökull's edges reveals landscapes that were covered by ice just decades ago, showing how quickly post-glacial succession establishes vegetation on newly exposed ground while providing real-time examples of how ecosystems colonize terrain after glaciation. Jökulsárlón, the Glacial Lagoon. Where Vatnajökull's Breiðamerkurjökull glacier meets the Atlantic, icebergs calve into a glacial lagoon that has expanded dramatically since forming in the 1930s, creating a landscape that demonstrates accelerated geological change while providing one of Iceland's most photogenic locations where ice, water, and volcanic beaches collaborate. The lagoon's icebergs range from white ancient ice to blue compressed ice to black ash-laden ice from volcanic eruptions, creating floating sculptures that demonstrate glacial history while slowly melting and calving into smaller pieces that drift toward the ocean. Seals frequent the lagoon while feeding on fish that enter from the ocean, demonstrating how quickly marine life adapts to new ecosystems created by retreating glaciers. This lagoon didn't exist a century ago, yet now supports complex food webs that include marine mammals. Diamond Beach, where ice meets fire's legacy. Across the road from Jökulsárlón, Diamond Beach creates surreal landscapes where glacial icebergs wash onto black volcanic sand, creating contrasts so dramatic they seem artificially arranged, demonstrating how Ice Age remnants meet volcanic activity's permanent legacy, while ocean currents and tides arrange natural sculptures daily. The black sand comes from volcanic rock ground into fine particles by millennia of wave action, while the ice represents water frozen thousands of years ago during climate conditions different from today. Their meeting creates temporary art installations that change with every tide while demonstrating Iceland's dual volcanic and glacial nature. Are you amazed by Iceland's geological processes? Give this video a thumbs up and share it with anyone fascinated by how our planet continues creating itself. Now let's continue witnessing Earth's construction. Skaftafell, where glaciers meet volcanoes. Within Vatnajökull National Park, Skaftafell demonstrates how glaciers and volcanoes create compound landscapes where ice-carved valleys meet volcanic peaks, while black sand plains transition to glacier tongues, creating environmental gradients that support diverse ecosystems within small geographic areas. Svartafoss waterfall drops over hexagonal basalt columns that inspired the design of Reykjavik's Hallgrímskirkja church, demonstrating how geological formations influence human architecture while showing how columnar jointing creates geometric patterns when lava cools at specific rates. Hiking trails through Skaftafell reveal how quickly vegetation establishes on glacial moraines, while distant views of Vatnajökull volcano, which produced Iceland's largest historical eruption in 1362, remind visitors that this peaceful-seeming landscape can transform dramatically when volcanic and glacial processes intersect catastrophically. Reynisfjara, Black Sand Cathedral. Iceland's most famous black sand beach demonstrates how basalt, wave action, and time collaborate to create coastlines unlike any other, while basalt sea stacks and columnar cliffs show how volcanic rock formations create natural architecture that rivals human construction for dramatic impact. The Reynisfjara sea stacks represent legend-made stone. Icelandic folklore claims they're trolls caught by sunrise and turned to rock, while geology explains them as remnants of a volcanic plug eroded by Atlantic storms that continue reshaping this coastline through wave action that generates some of the world's most dangerous surf. Columnar basalt formations in the cliff faces create natural cathedrals, where hexagonal columns demonstrate how cooling lava creates geometric perfection through processes that follow physical laws governing crystal formation when molten rock cools at specific rates and pressures. Cave formations at beach ends show how wave action carves volcanic rock while creating temporary refugees that can become deadly traps when tides rise, demonstrating how Iceland's dramatic beauty comes with dangers that demand respect and awareness from visitors unused to environments where geology remains actively dangerous. Seljalandsfoss and Skógafoss, glacial power on display. These two waterfalls within kilometers of each other demonstrate different aspects of how glacial rivers carve landscapes while creating photography opportunities that have made them among Iceland's most visited natural features, each showing distinct ways water shapes volcanic terrain. Seljalandsfoss allows visitors to walk behind the falling water, where the waterfall has eroded a cave into the cliff face, providing perspectives on waterfalls impossible at most locations, while demonstrating how water exploits weaknesses in volcanic rock to create voids that eventually collapse into caves and alcoves. Skógafoss drops 60 meters with enough power that its spray creates constant mist while producing rainbows on sunny days. The waterfall's position marks the ancient coastline before post-glacial rebound raised the land, demonstrating how Iceland's relationship with the sea continues changing as the island rises after glacial weight removal. The rivers feeding these waterfalls originate from glaciers visible in the distance, creating connections between Ice Age remnants and modern landscapes while demonstrating how glacial meltwater continues as the primary force shaping Iceland's river systems and coastal features. Landmannalaugar, rhyolite rainbow mountains. In Iceland's highlands, Landmannalaugar showcases rhyolite mountains painted in reds, yellows, blues, and greens through mineral oxidation and geothermal alteration, creating landscapes so colorful they seem artificially enhanced, while demonstrating how different volcanic rock compositions create distinct appearances when subjected to weathering and mineral alteration. Natural hot springs at Landmannalaugar allow hikers to bathe in geothermal waters while surrounded by multicolored mountains, creating experiences where geological education and physical comfort merge. These springs demonstrate how volcanic heat continues warming Iceland's interior while providing amenities that make harsh highland environments hospitable. Hiking trails through the area include the Laugavegur Trek, consistently rated among the world's best multi-day hikes for diversity of landscapes encountered. From rhyolite peaks to black sand deserts, from hot springs to snowfields, all within a few dozen kilometers, demonstrating Iceland's geological density. The area's obsidian fields show where rapid lava cooling created volcanic glass that ancient peoples valued for tool-making, while modern visitors marvel at its reflective properties, connecting geological process with human cultural development, while showing how volcanic activity provides both hazards and resources. Askja Caldera, volcanic heart of Iceland. Deep in Iceland's uninhabited interior, Askja demonstrates active volcanism through a caldera formed by collapse after magma chamber evacuation during the 1875 eruption that forced many Icelanders to emigrate. The caldera now contains 2 lakes, including Viti Crater Lake, where geothermal activity keeps water warm enough for bathing despite harsh highland conditions. Access to Askja requires 4x4 vehicles and river crossings that emphasize how much of Iceland remains wilderness, where geological processes proceed without human observation. This caldera erupted multiple times in the 20th century, yet remains little known compared to more accessible volcanic features. The area's obsidian desert and pumice fields demonstrate how explosive volcanic eruptions distribute materials across vast areas while creating surfaces so hostile that vegetation takes decades to establish, showing that even in Iceland's relatively quick ecological succession, some volcanic landscapes resist life's colonization for extended periods. NASA used the Askja area to train Apollo astronauts for lunar missions due to its otherworldly volcanic terrain, demonstrating how Iceland's active geology creates landscapes that resemble other planets while remaining terrestrial, connecting Icelandic volcanism with space exploration through visual similarity. Northern Lights, Earth's atmospheric display. Iceland's position just below the Arctic Circle creates optimal conditions for witnessing aurora borealis, the northern lights that result when solar particles interact with Earth's magnetic field and atmosphere, creating light displays that demonstrate our planet exists within the solar system's broader electromagnetic environment. The aurora's green, pink and purple curtains of light demonstrate atmospheric physics, where different gases emit distinct colors when energized by solar wind particles channeled by Earth's magnetic field toward polar regions. Iceland's dark winter nights and clear Arctic air create conditions where these displays appear frequently and dramatically. Traditional Icelandic folklore interpreted auroras as spirits or omens, while modern science understands them as demonstrations of how our planet's magnetic field shields us from solar radiation, connecting ancient wonder with contemporary understanding, while neither explanation diminishes the aurora's visual impact. Optimal viewing occurs during dark months from September through April, when Iceland's high latitude and long nights create conditions where auroras can appear for hours, creating opportunities for photography that captures both geological landscapes and atmospheric phenomena in single frames. Conclusion: a planet's autobiography. From tectonic plates pulling apart in real time to glaciers carving valleys while you watch. From volcanic eruptions you can approach safely to hot springs that harness Earth's interior heat. Iceland demonstrates that our planet remains a work in progress, a living laboratory where creation continues at speeds that make geological processes comprehensible. These 12 phenomena barely begin to catalog Iceland's geological wonders. Every valley, every lava field, every hot spring tells the same story. Earth is still being born, and nowhere on the planet can you witness this creation more dramatically than on this volcanic island perched atop the mid-Atlantic ridge. What makes Iceland truly extraordinary is how it demonstrates that geological timescales and human timescales can intersect. Volcanic eruptions occur every few years. Glaciers retreat measurably annually. New hot springs appear, while landscapes that formed just centuries ago look ancient. Compressing geological process into timeframes humans can observe and understand. Thank you for witnessing Earth's creation with Travel Earth Adventures. If this journey through active geology has inspired you to experience our planet's dynamic nature, give this video a thumbs up and tell us which geological process amazed you most. Subscribe to Travel Earth Adventures and hit that notification bell to continue exploring destinations where our planet reveals its secrets while creating landscapes that will amaze future generations. Your support allows us to document Earth's most extraordinary process as they happen. Until our next adventure into places where Earth reveals its creative power, travel curiously and remember that the ground beneath your feet is part of a planet that continues evolving. Bless fellow Earth observers.